Objective 2. Use the conditional distribution to identify association among categorical data. Now, as we look at the information in both tables above, we might ask whether a higher level of education is associated with a higher likelihood of being employed. Now, if the level of education does not play a role in employment status, we would expect the relative frequencies for employment status at each level of education to be close to the relative frequency marginal distribution for the employment status given in the blue here on the right in Table 10. So we would expect that this represents 61.7, right? So that means 61.7 of the individuals, okay, in the employment status of employed did not finish high school. Okay, we also know that 61.7% of individuals who finished high school. We also know that there is 61.7% of the individuals with some college. And then we also have 61.7% of the individuals with at least a bachelor degree to be employed. Now, if relative frequencies for these various levels of education are different, we might associate this difference with the level of education. Now, the marginal distributions in both tables allows us to see the distribution of either the row variable, okay, so the row variable is the employment status, which means that all of these values, okay, or the column variable, which is the level of education. So the column variable would then be each of these columns, okay? But we do not get a sense of association between employment status and level of education from these tables. To learn about any association that may exist, we need a different table. Now, in this example, we are going to compare two categories of a variable by using the data in the table below to answer parts A through D. So, in the first question, it's asking us, what proportion of those did not finish high school is employed? Okay, so we're asking those who did not finish high school. So those who did not finish high school has a total in the column of 22,863. Okay, now we also want to know the employed row. So that means that this represents the amount that's employed. Okay, and then we're looking at the total amount here at 22,863. So we are asking, among the individuals who did not finish high school, what proportion is employed? So to determine this proportion, we're going to divide the number of employed individuals, which is 9,671, who did not finish high school, by the number of people who did not finish high school, which was 22,863 individuals that are 25 years and older who did not finish high school. So that means that we're going to take the value of 9,671 and then we're going to divide it by the total in that column, which gives us 0.423. So therefore 0.423 represents the proportion of individuals who did not finish high school who are employed. Okay, the next question says, what proportion of those who are high school graduates is employed? So what we're looking for now is, okay, here is the high school graduate number that is employed. So we would say that 34,211 represents the individuals who are employed with the high school graduate. And we're going to divide it by the total number in that column. So the total number in that column, okay, is 62,314. So if we take that value and divide it by 62,314, then we get 0.549. Therefore, 0.549 represents the proportion of high school graduates who are employed. Okay, next it says, what proportion of those who finish some college is employed? So again, what are the values of the students that are employed that finish some college? Well, we can see here that that number represents 35,941. So that's the number that's in our numerator. Okay, and then we're dividing it by the total in that column. Well, the total in that column for some college is 56,779. So we're going to take 35,941 divided by 56,799 to get 0.633. So therefore, 0.633 represents the proportion of individuals who finish some college who are employed. Now, in Part D, it says, what proportion of those who have at least a bachelor's degree is employed? So again, we're going to use the number that's associated with employed in the bachelor's degree. And we know that in the column of bachelor's degree, the total is 74,562. So we know that the number in the numerator is 53,760, which represents the bachelor's degree that's employed, and then dividing it by the total in that column, which is 74,562, to give us 0.721. Therefore, 0.721 represents the proportion of individuals with at least a bachelor's degree who are employed. Now look back through the relative frequencies found in parts A through D. Notice that as the amount of education increases, the proportion of individuals employed also increases. So here we can look at this as a percentage, 42.3% to 54.9% to 63.3% to 72.1%. Now, conditional distributions. Conditional distributions, the variable we condition upon represents the explanatory variable in a conditional distribution, and the other variables becomes the response variable. So for example, we would like to know if level of education plays a role in determining one's employment status. Therefore, level of education is the explanatory variable and the employment status is the response variable. So we hold level of education fixed in determining the employment status of individuals at each level of education. From that example, or example 3, it appears that as level of education increases, the proportion employed increases. However, the results in example 3 are only partial, because in general, we create a relative frequency distribution for each value of the explanatory and response variables. So for our example, this means that we would construct a relative frequency distribution of employment status for individuals who did not finish high school, a second relative frequency distribution for individuals who are high school graduates, and so on. These relative frequency distributions are called conditional distributions. A conditional distribution lists the relative frequency of each category of the response variable, given a specific value of the explanatory variable in the contingency table. So let's take a look at another example here. In this example, we're constructing a conditional distribution. We want to find the conditional distribution of the response variable employment status by level of education, the explanatory variable for the data that's in this table. What is the association between level of education and employment status? So this was the given table, and now we're going to create a new table for the conditional distribution. Now we want to compute the relative frequency for each employment status, given that the individual did not finish high school. Then we're going to compute the relative frequency for each employment status, given that the individual is a high school graduate. And then we're going to continue computing the relative frequency for each employment status for the next two levels of education. So let's take a look here. We know that the employed here represents 9,671, so that's what's in our numerator. And then we're looking at the total. So the total here is 22,863. And then that gives us a relative frequency of 0.423. Okay, and then in the employment status, we're going to take the 34,211 for the high school graduate, and then we're going to divide that by the total in that column, which is 62,314, to get 0.549. And then again, in the employment status, we're taking 35,941, dividing that by the total here for the sum college to get 0.633. And then we're going to take the last bachelor's degree or higher, which is 53,760, and then divide that by the total of 74,562 to get 0.721. And now we're going to continue to the next one, which is the unemployed. So the unemployed here represents 628. And again, we're dividing it by the total in that column, which was 22,863. And that gives us 0.027. Again, we're going to take the next value of 1,697 and then divide it by the total in that column, which is 62,314, to get 0.027. And again, we're taking the unemployed for the sum college, 1,492, and then dividing it by the total in that column, which is 56,799, to get a frequency here, a relative frequency of 0.026. And the last number in that row is 1,278, which represents the bachelor's degree or higher, and then dividing it by the total in that column, which is 74,562, to get 0.017. Okay, and the next one, the next row is the not in labor force. So we know that the value of that in the first row is 12,564, and then dividing it by the total in that first column gives us 0.550. Okay, the next one for high school graduate is 26,406, and then dividing it by the total in that column of 62,314 gives us a relative frequency of 0.424. Okay, next we have a total here of some college for the not in the labor force of 19,346 divided by the total of in that column of 56,779 to give us 0.341. And then the last row of not in the labor force for a bachelor's degree or higher is 19,524. And then we're dividing it by the total in that column of 74,562 to give us 0.261. If we add up each relative frequency for each column, you will see that we're going to get a total of 1 for each of those columns. So again, the table shows the conditional distribution by level of education. Notice that the denominator in each column is fixed at the number of individuals at that level of education. Looking at the conditional distribution of employment status by level of education, associations become apparent. If you read the information in the table from left to right, as the amount of schooling, the explanatory variable, increases, the proportion employed within each category also increases. As the amount of schooling increases, the proportion not in the labor force decreases. So the proportion unemployed with a bachelor's degree is much lower than those unemployed in the other 3 levels of education. Now, information about individuals' levels of education provides insight into their employment status. So, for example, we might predict the number of employed individuals out of 100 to be about 62 because the employment rate for the entire United States is 61.7%, which is what we got down here. Okay, however, we would change our guess to 72% if we knew that the 100 individuals had at least a bachelor's degree. So do you see why? So the association between level of education and employment status allows us to adjust our predictions between those two tables.